space telescopes have revealed unusual views of Jupiter, and the James Webb Telescope captured this image. The state-of-the-art telescope also spotted interesting city-like lights more than 7 trillion kilometers from Earth while observing Proxima Centauri B, our nearest planet. The discovery that advanced civilizations may arise outside of our solar system has excited scientists and space enthusiasts who have long been waiting for signs of extraterrestrial life. Lights that resemble the lights of a distant city indicate the presence of a race set on Proxima Centauri. If confirmed, this development would be an important step in proving the existence of intelligent life beyond Earth. The scientific community is both surprised and hopeful about this possibility. This unprecedented finding suggests that advanced civilizations might exist outside our solar system, fueling the idea that sentient life may have been waiting for us to develop the technology to find it. David Kipping, a Columbia University astronomer, notes that Proxima Centauri B is particularly difficult to study due to its unique heating pattern, which differs from typical rocky planets. Unlike other planets that absorb sunlight and emit infrared radiation predictably, Proxima Centauri B has a distinct infrared signature from its star, Proxima Centauri, making it an intriguing subject for further research. The James Webb Space Telescope, JWST, has played a crucial role in this discovery by capturing Proxima Centauri B's unique thermal signature with its advanced infrared capabilities. This will allow scientists to explore the exoplanet's atmosphere and assess its ability to support life. JWST's ability to detect faint signals from space is ideal for unraveling the mysteries of this distant world, including the city-like lights seen at night. Specially designed to see low light, this telescope is perfect for seeing artificial or bright light. Proxima Centauri B's unique thermal and atmospheric properties are an attractive subject for further study. The Earth's surface and stellar conditions interact in complex ways to produce differences in temperature and heat distribution between day and night. The far side of Proxima Centauri B's sun may have large solar panels that absorb energy from the star and turn it back into the moon. If the exoplanet has an atmosphere, the temperature difference will moderate and become more stable. If there is no wind, the temperature difference will be large. The day side will be very hot and the night side will be cold. Understanding this temperature change is important to assess the composition of Earth's atmosphere. JWST's advanced infrared imaging may reveal the planet's thermal radiation, and Proxima Centauri B may not have a gas. The detection of gases such as oxygen, water vapor, and methane indicates their presence. However, JWST could not detect a small amount of oxygen, which is an important sign of life. Despite this limitation, the telescope is important for detecting other signs of life, such as ozone. Future telescopes and observers will be able to detect these elements in exoplanets. While JWST will be able to study some potentially habitable planets, the upcoming Large Space Telescope, ELT, which will begin operations in 2028, will provide more insight into the atmospheres of exoplanets. The ELT data provide a clearer picture of the habitability of these planets and the potential for life elsewhere in the universe. With the launch of new telescopes, JWST will have a great opportunity to explore distant places, despite its limitations. Understanding the real world can lead to great discoveries. This telescope points to the future of exoplanet exploration and shows the potential to improve space exploration and instrumentation. The main goal of future telescopes is to improve the detection of faint light from exoplanets by reducing the brightness of their host stars. Current techniques include the use of internal eyes or large external satellite umbrellas to block out the starlight and focus more on reflected light from Earth. It's like shading your eyes so you can see something far away better. If successful, these techniques will help scientists analyze the world's atmosphere and assess its climate. However, significant challenges remain, such as distinguishing gases from biological versus geological sources, which complicates the search for life. Many essential life gases can also come from non-biological processes, risking false positives. Despite these hurdles, astronomers are committed to refining their methods to detect genuine signs of life and filter out false signals. The James Webb Space Telescope's early findings offer a promising glimpse into the future of exoplanet exploration. As humanity pushes further into space, ongoing research is expected to reveal more about the universe and our place within it. The quest for extraterrestrial life continues strongly, Despite decades of effort, the discovery of city-like lights on Proxima Centauri B may be the closest humanity has come to finding evidence of extraterrestrial life. Whether these lights will prove to be humanity's long-sought answer or present a new mystery, the quest to uncover the unknown persists. This endless curiosity about why we are alone in the universe has fueled discussion, research, and ideological debate throughout history. Today, the search for extraterrestrial life is a major scientific endeavor driven by advanced technologies to probe deep space for clues. At the center of this mission is the James Webb Space Telescope, JWST, our most advanced instrument for exploring the universe. Once considered the stuff of science fiction, many scientists now believe that aliens can. The search for extraterrestrial intelligence, SETI, founded in 1984 by Jill Tarter and Thomas Pearson, aims to detect intelligent life through radio signals. Radio waves, unlike other types of radiation, can travel long distances with little dispersion. SETI is using the Allen Telescope Array in California to look for these signals, although no definitive evidence has yet been found. Despite this, Tarter is hopeful and encourages public participation in the search. Excitement surged throughout the scientific community when the James Webb Space Telescope, JWST, detected what appeared to be city-like lights on Proxima Centauri B, a planet located just over 4 light-years away from Earth. This incredible discovery immediately sparked widespread speculation and hope, as many wondered if these lights might be artificial in origin, potentially providing groundbreaking evidence of an extraterrestrial society. If proven to be the result of intelligent activity, such a finding would be one of the most significant discoveries in human history. It would confirm what generations of scientists, philosophers, and dreamers have long hypothesized: that we are not alone in the universe. Proxima Centauri B has long been a subject of intrigue, given its status as the closest exoplanet to our solar system. Proxima Centauri is the smallest and faintest star in the Alpha Centauri star system. The planet is believed to be in the star's habitable zone, the area around the star where conditions are favorable for liquid water and life. Because of this proximity and being in the habitable zone, Proxima Centauri B is one of the most important targets for the search for extraterrestrial life. But finding signs of life on these distant worlds is still a big challenge. Meanwhile, the James Webb Space Telescope, launched in December 2021, has proven to be an amazing tool for exploring space. JWST will orbit the Sun within 1 million miles of Earth and stop at what is known as the second Lagrange point, L2, where it will remain stationary and leave Earth's shadow. There is no barrier. This unique view gives JWST the ability to record detailed views of distant celestial objects, beyond what is possible with previous telescopes. JWST has some of the most advanced technology ever deployed in spacepoint. One of the main functions is the ability to see in infrared light. Unlike visible light, infrared wavelengths penetrate the planet's dust and reveal features that are otherwise hidden. This is especially useful when studying exoplanets like Proxima Centauri B, as infrared light helps scientists peer through the layers of its atmosphere and detect subtle chemical signatures. This ability to observe in the infrared spectrum is what makes the JWST particularly effective at searching for signs of life, such as the detection of gases like carbon dioxide, methane, and water vapor, key indicators that suggest the possibility of habitability. In addition to its ability to analyze exoplanet atmospheres, the JWST is capable of detecting extremely faint light. This is particularly important when studying distant planets like Proxima Centauri B, as any potential signals, whether natural or artificial, are likely to be incredibly weak due to the vast distances involved. Yet the JWST's sensitivity allows it to pick up even the faintest light sources, making it an ideal tool for investigating the mysterious city-like lights observed on Proxima Centauri B. Whether these lights are of natural origin or artificial light signals created by the intelligent world is unknown. However, the possibility itself has sent a wave of excitement around the world. If these lights appear to be artificial, they will show the first signs of the outside world. For decades, scientists have speculated about the existence of intelligent life beyond Earth, but there is no concrete evidence. Radio signals, such as those searched for by the Search for Extraterrestrial Intelligence (SETI) program, have long been considered a possible way to identify aliens. However, there are no visible signs at this time. The discovery of artificial light on a distant exoplanet changed everything. Unlike radio waves, which can travel long distances in space, the light emitted from the planet shows society's ability to generate energy, whether through technology or through structures such as cities. The implications of this discovery are profound. Not only does it confirm that intelligent life exists elsewhere in the universe, but it opens new avenues for understanding extraterrestrial evolution. How advanced is this potential community? What kind of technology do they have? Do they understand our life? These are just some of the questions that scientists and researchers will seek to answer if the existence of extraterrestrial life is confirmed, while the scientific community waits to reanalyze the data collected by JWST. Scientists are closely examining the city-like lights to determine their nature and origin. Scientists hope to use JWST's infrared capabilities to gather more data so they can analyze the chemical composition of the atmosphere around Proxima Centauri B. This knowledge allows them to determine whether the lights seen are artificial or the result of natural phenomena. Finally, the discovery of city-like lights on Proxima Centauri B by the James Webb Space Telescope has given new excitement and hope in the search for extraterrestrial life. The prospect of finding evidence of an advanced universe just a few light-years away is exciting, and the scientific community is ready to begin a new phase in the exploration of our universe. The potential implications of such a discovery could redefine our understanding of the world beyond Earth and inspire future generations.